this video, I'm going to discuss the key points related to correlational research design. We'll look at the primary types of correlation designs, the key characteristics of correlational designs, how data is presented, how to interpret a correlation coefficient, approaches to correlational research, potential ethical issues, and a basic overview of how correlational research is conducted. At some points during the video, you'll be asked to pause the video so that you have the opportunity to apply what's been presented.
So first, what is correlational research design? It's a design where researchers use statistics to determine the relationship or degree of association between two or more variables. As noted in the previous slide, correlation allows us to determine the relationship or association between two or more variables. Correlation does not allow us to establish causation. For example, while there is an association between ice cream sales and shark attacks, the mere presence of an association does not suggest that one variable is causing another. For example, from this information alone, we only know that ice cream sales and shark attacks are associated with one another. One may cause the other, or there may be a third variable, such as outside temperature, that is contributing to this relationship. Consider, for instance, a researcher who has hypothesized that viewing violent TV is associated with aggressive play in children. The researcher has collected from a sample of children a measure of how many violent TV shows each child views during the week, as well as a measure of how aggressively each child plays on the school playground. From this collected data, the researcher then discovers a correlation or association between the two measured variables. More specifically, he notes that as one variable, viewing violent TV, increases, so too does aggressive play. However, just based on this information, we don't know if viewing violent TV actually causes aggressive play to increase, if aggressive play increases a child's tendency to watch violence on television, or if there's a third variable, such as a parent's discipline style that causes both viewing violent TV and aggressive play to increase. There are two primary types of correlational designs. These include explanatory and prediction. In explanatory designs, the researcher is interested in the extent to which two variables covary. In other words, the changes we might see in one variable as another one changes. In this research, the researcher attempts to explain the association between or among variables, correlates two or more variables, collects data at one point in time, and obtains at least two scores for each individual in the group. For example, let's say we do a study to determine the strength of the relationship between the amount of time a child spends in high-quality preschool and their social competence in kindergarten. Quality preschool is the explanatory variable, and social competence is the response variable. This means that we're hoping the high-quality preschool will explain social competence in kindergarten, or you can say we're hoping that social competence in kindergarten responds to high-quality preschool. In prediction designs, researchers seek to identify variables that will predict an outcome or criterion. In this form of research, the investigators identify one or more predictor variables and a criterion. They measure the predictor variables at one point in time, and the criterion variables at a later point in time, and they forecast performance.
For example, in a study entitled Early Educational Milestones as Predictors of Lifelong Academic Achievement, Midlife Adjustment, and Longevity, published in the Journal of Applied Developmental Psychology, where follow-up data from the term and life cycle study was gathered and analyzed, researchers attempted to examine how age at first reading and age at school entry relate to grade school academic performance, lifelong educational achievement, midlife health, mental adjustment, and longevity across 8 decades. What are the predictor variables? What are the criterion variables? Please pause the video to answer the questions. If you said that the predictor variables are age at first reading and age at school entry, you are correct. And if you said that the criterion variables are grade school achievement, school academic performance, lifelong educational attainment, midlife health, and mental adjustment and longevity across 8 decades, you were also correct. If you said prediction, you were right. This is an example of prediction because the author sought to determine if the factors of maternal sensitivity and maternal depression predicted EEG asymmetry. In addition, the author found that EEG asymmetry of the 6-month-old infants predicted their greater emotionality at 6 months. Quiz yourself again and pause the video and consider what factors were the predictor variables.
The predictor variables were maternal sensitivity and maternal depression. EEG asymmetry of 6-month-old infants also became a predictor variable, as it was able to predict a criterion of greater emotionality at 12 months. Correlational designs have specific characteristics. First, in correlational designs, the researcher can display their scores. One way to display scores is through the use of a scatter plot. A scatter plot helps to provide a visual representation of the association between two scores for each participant and allows us to see overall patterns. The scores are typically identified as X and Y. So, for example, if a researcher were investigating the relationship between height and weight, as seen in the image here, height is located on the X-axis and weight is located on the Y-axis. This data was easily collected by measuring a child's height in inches and measuring a child's weight in grams. The data for each individual was then plotted on a graph. A dot on the graph is a representation of one individual's weight and height. The means for data collected can also be plotted on the scatter plot so that the reader is provided with more visual detail and where the individual's height and weight fall into relation to others. An example of this can be found in your textbook on page 344. Another way to display scores is in a correlation matrix. In this correlation matrix, we can see that a child's empathy has a positive 0.61 correlation with a mother's empathy. We can also see that a mother's demonstration of understanding the child has a positive 0.4 correlation with a child's empathy level, and so forth. We can also see the level of significance by referring to the asterisks and crosses that some correlation coefficients have. We will be discussing what these numbers and their signs mean shortly. Correlation coefficients are typically determined through the use of statistical software. However, the formula is presented here. So what do the scores mean? To discuss this, let's consider the example of gestational age and birth weight. In this example, a researcher has collected 2 data points for several infants. 17 of those data points are presented here. These data points are gestational age in weeks and birth weight in grams. We may look at this data and casually observe a pattern, but it isn't until we calculate the correlation coefficient that we know if there is indeed an association, the strength of the association, and the direction of the relationship. In this scatter plot, you can see that each infant's gestational age and weight have been plotted. Gestational age in weeks is on the x-axis, and birth weight in grams is on the y-axis. You can casually observe a pattern suggesting that the greater the gestational age, the greater the birth weight, or the greater the birth weight, the greater the gestational age. You can also see at the top that a correlation coefficient of positive 0.82 has been determined. So what does this number and the sign next to it mean? Well, there are 2 important components of a correlation coefficient, the sign and the number. Let's first examine the sign. Correlations can be negative or they can be positive. Positive correlations exist when as one variable increases, the other variable tends to increase as well, or as one variable decreases, the other variable tends to decrease too. In other words, both variables are moving in the same direction. Negative correlations exist when as one variable increases, the other variable tends to decrease. Take the example presented. As the variable of cigarettes consumed increases, the variable of health tends to decrease. We could also say that as the variable of health decreases, the variable of cigarettes consumed tends to increase. As stated earlier, correlational research alone cannot establish a cause and effect relationship. So in this example, we don't know if cigarette smoking causes a decline in health, or if a decline in health causes an increase in cigarette smoking, or if there is a third variable associated with the observed relationship, such as stress levels that may lead to an increase in smoking and lead to a decrease in health. We only know this from the research that there is an association. Here Here is another example of a positive correlation, where people who feel in control tend to have greater life satisfaction. Or we could also say that people who have greater life satisfaction feel that they have greater control over their lives. A negative correlation example is also presented. People who go through many negative life events have a feeling of less control in their lives. As one variable increases, negative life events, the variable of perceived control tends to decrease. The strength of the correlation is determined by the number, and that number is independent of the sign. So we could say that the strength is really the absolute value of the number presented. You can see in the diagram presented that the closer the number is to 1, the stronger the relationship is said to be between the two variables. And the closer the number is to 0, the weaker the relationship is said to be between the two variables. So now, based on an understanding of what the sign and number of a correlation coefficient indicates, you can see that first, the correlation coefficient is positive, so that as gestational age goes up, so too does birth weight, and the number is close to 1, so the relationship is strong.
So let's test your understanding. All of the following variables except for blank would likely show a positive correlation: height and weight, men's educational level and their income, alcohol consumption and scores on a driving test, or school grades and IQ scores.
If you chose C, alcohol consumption and scores on a driving test, you were correct. This is because as alcohol consumption goes up, scores on a driving test would tend to go down. As discussed earlier, we can also note the relationship between two variables by looking at the plotted scores. In the example provided on this slide, you can see 5 potential patterns of association. The first 2 examples, scatter plots A and B, are linear relationships. A positive linear relationship is one where one variable increases as the other increases. For example, the variables of birth weight and gestational age would show a pattern that looks like this. A negative linear relationship is one where, as one variable increases, another one tends to decrease. For example, the variables of gestational age and risk for developmental delays would show a pattern that looks like this, so that the lower the gestational age, the greater the risk for developmental delays. C is, of course, an example of no correlation. Examples of a curvilinear correlation or nonlinear relationship can be seen in D and E. These can be sources of misleading correlation coefficients because the data points balance out each other, which can lead to a lower correlation coefficient, causing one to think that there is less of a relationship than truly exists. Therefore, researchers use other statistics, such as Spearman-Rowe, to calculate the relationship between variables when a curvilinear relationship.
So now that we've reviewed the two components of a correlation coefficient and scatter plots, select the scatter plot that's associated with the statements provided. Pause the video to do so.
Now check your answers. In some studies, researchers may be interested in studying more than 2 variables. In this case, the researcher needs to determine the weight or impact of each variable. One type of multiple variable analysis is partial correlation. Partial correlations measure the strength of a relationship between 2 variables while controlling the effect of one or more other variables. For example, you might be interested in determining the relationship between social competence in preschool children and prosocial behaviors exhibited by the teacher. Because you know that age may affect the relationship, a partial correlation will allow you to control for this effect. What other variables do you think a researcher might want to control for? Might they want to control for sex of a child, constructivist versus traditional classroom, socioeconomic status? Can you think of any additional ones? Another type of multiple variable analysis is multiple regression. Let's imagine I want to be able to predict a child's weight. Since I know based on the literature that there are multiple variables that can contribute to a child's weight, I select the ones of interest and collect data on multiple children. So let's imagine that I've collected data on female children. This is some of the example data shown. Using all of my data, I'm able to then use an equation to establish regression coefficients for each variable to predict the weight of a child given specific variables of daily physical activity, daily calorie consumption, and age. For example, I can determine the overall weight each variable has on my dependent variable of child weight in pounds. This weight is represented in what is called beta weight. So in the example I've provided, the beta weights of each variable are provided, which I've made up to demonstrate the concept. Which beta weight appears to contribute the most to the most variance in child weight? We can see from this table that the variable that explains the most variance in child weight is age, the second most variance is calories consumed, and the third most variance is daily physical. Here's an example of a correlational study published in the American Journal of Public Health. The research question posed was, what is the association between parents' income, mother's vocabulary, and early child cognitive development in a sample of poor children in rural Ecuador? The statistical approach used was multiple regression. We may look at the results provided and wonder if observed parental education and maternal vocabulary associations with child cognitive development are mediated by child nutritional status or household wealth. By controlling for such variables, the researcher was able to show that the coefficients on maternal schooling and vocabulary generally change only modestly when variables for child nutritional status and household wealth are included in the regressions. Thus, it does not appear that the main reason for better performance of children with mothers who have more schooling and richer vocabulary levels is the fact that these children are less poor or have better nutritional status. We can see from this example how useful the ability to make such predictions in child cognitive development are, as this can lead to potential social service interventions or programs to focus on increasing maternal education levels. Another type of multiple variable analysis is meta-analysis. A meta-analysis is a systematic procedure for deriving conclusions from a large number of studies that allows the researcher to determine effect size. Effect size is a standardized measure of the variables that we're studying. This would allow the researcher to get a truer or clearer picture of the relationship between the independent and dependent variables of interest. The researcher is able to assign more numerical weight to the study that is stronger. Then smaller studies that we may not rely as much on, we can give a lower weight. There are 6 steps involved in meta-analysis that you can see listed here. First, the researcher needs to identify the problem and be able to locate enough studies on the subject matter of interest. Second, the researcher needs to search databases and gather studies. They do so using a systematic approach. Third, the researcher needs to develop criteria for the review of studies. The researcher then codes the studies based on criteria they've established. Fourth, the researcher needs to determine the effect size. When doing this, they will note the effect size of each study and then average those. Fifth, the researcher will calculate what is called a summary effect. When doing this, the researcher will compare the effect size or different subgroups to determine what accounts for the variation in effect size. Finally, the researcher will interpret the meaning of the summary effect across all of the studies to determine the magnitude of these effects. There are also more advanced correlational statistical procedures available to researchers. These are listed and briefly described in your textbook on pages 355 to 356. There are multiple ethical issues that may arise that are related to data collection, analysis, reporting, and presenting. First, it's important to measure important controls such as age and gender that may explain the relationship or serve as a predictor for what you've observed. Second, it's important to report all data and share important information such as effect size. Third, it's important to report contradictory findings and share any negative findings or explanations. And fourth, it's important to share your results. There are several steps involved in conducting a correlational study. The first step involves determining if a correlational study best addresses the research problem. Since groups are not being compared in a correlational study, research questions such as, is secure attachment between a parent and child related to social competence in children, might be appropriate. A second step involves identifying who you will study. It is ideal to select a sample that represents the population. Data collection should only commence when permission is given by those who are responsible and the institutional review board. In the third step, the researcher needs to identify 2 or more measures for each individual in the study. Instruments used should have high validity and reliability. During the fourth step, the researcher needs to collect data and monitor potential threats. There are three primary approaches to gathering data in correlational research. Data can be collected through naturalistic observation, where the researcher observes and records without directly controlling any variables. Data can also be collected through the use of survey research. In this instance, researchers administer surveys or questionnaires. This can be relatively quick to do, but the response rate may not be ideal, and those who tend to respond may have a common characteristic that will influence the results. The researcher can also conduct archival research to collect data for their correlational study. In archival research, the researcher analyzes data that was collected in the past. It may be difficult or time-consuming to access the data, and the researcher can't control how the data was collected if they're not the one who collected it. In step 5, the researcher analyzes the data and represents the results. When doing so, the researcher will use the selected statistical procedure or procedures to determine the strength of the relationship and the direction. More rigorous procedures, such as those discussed earlier, can also be used. At this point in the research, the researcher should also construct a scatter plot to determine if the relationship is curvilinear, which may result in lower associations than what actually exist. At this stage, the researcher will select the most appropriate statistical test. In the sixth step, the researcher will interpret the meaning of the results. When doing so, the researcher will need to consider the potential influence of intervening variables, interpret regression weights in a regression analysis, and develop a predictive equation if their study is a predictive study. So, if correlational research does not allow us to establish cause and effect, for what reasons might we choose to conduct correlational research? Correlational research is often conducted when a researcher cannot manipulate the independent variable because it's impossible, impractical, or unethical. Can you think of examples of correlational studies that would be unethical to conduct using experimental methodology? What about the relationship between level of nutrition in food consumed and child self-regulation? It wouldn't be ethical to randomly assign some children to not consume nutritious food and then to assign others to do so that we can see how nutritious food affects self-regulation. So we would use already existing variables. For example, we might administer a survey to the families of children asking them about the child's diet and then correlate that with the measures of self-regulation in the classroom. Now, in addition to having tested your understanding on previous slides, test your understanding on the next several slides. You'll be presented with multiple choice questions. Read each question, pause the video, and then press play to see the answers. Pause the video. Another way to display scores is in a correlation matrix. In this correlation matrix, we can see that a child's empathy has a positive 0.61 correlation with a mother's empathy. We can also see that a mother's demonstration of understanding the child has a positive 0.4 correlation with a child's empathy level, and so forth. We can also see the level of significance by referring to the asterisks and crosses that some correlation coefficients have. We will be discussing what these numbers and their signs mean shortly. Another way to display scores is in a correlation matrix. In this correlation matrix, we can see that a child's empathy has a positive 0.61 correlation with a mother's empathy. We can also see that a mother's demonstration of understanding the child has a positive 0.4 correlation with a child's empathy level, and so forth. We can also see the level of significance by referring to the asterisks and crosses that some correlation coefficients have. We will be discussing what these numbers and their signs mean shortly.